Hey, so in this video, we are going to learn everything there is to know about the Unreal Engine physics constraint, and we're going to do that through the medium of the hot dog. So the first thing we're going to have to do is we have to make our hot dog, and to do that, we're going to use Blender. Now, I'm not great with Blender, so I'm not going to try and teach you how to use it, and I'm probably going to do some things in a slightly inefficient way when I'm doing this. If you want to learn Blender, if you don't know your way around Blender yet, then if you're an artist, you really should know your way around Blender. If you're a system designer, it's really worth knowing your way around Blender as well, because it's really useful for making like little placeholder objects and knocking up quick shapes to build things with. So I'm going to go quite quickly through the Blender part. I hope you can keep up, and also please excuse it's probably not the most efficient way of working. It's just how I've learned it. Okay, so here we are in Blender, and the first thing I'm going to do is I'm going to delete everything that's in the default scene, because I don't want to start with a cube, and we're not going to render anything, so we don't need a light or a camera. We're going to add a sphere, and I'm going to go into edit mode and look at this from the side and get right in here, and I'm going to just select half the sphere here, delete a bunch of vertices, and then of course you need to get the other half from the other side that we just revealed, and there we go. And so now we have half a sphere, so we have the end of our hot dog. I'm going to duplicate that, Shift and D, and then I'm going to turn on snapping up here, and I'm going to make sure that it works for move and for rotate. And I'm going to take our newly duplicated hot dog, and I'm going to move it. Let's do this in the side view. 1, 2, 3, 4, 5. Let's do that. Okay, and we're going to rotate it so we're looking down X right now. Let's rotate it 180 degrees. And let's take this, and we're going to do 1, 2, 3, 4, 5. So we've got the same distance between both ends. Yep, okay. So we're going to take these and we're going to join them. And while we're here, we're going to shade smooth. So we want a nice smooth hot dog. And then I'm going to go to edit, and we're going to select the edge loop here. I never remember my shortcuts. Sorry, Blender aficionados. Now, we could just, if I press E here to extend, we could just extend this all the way down here and we'd get a hot dog. But we want our hot dog to be able to deform with physics, and it's going to deform around the vertices that we give it. I could do this through subdivision and things, but I'm just going to do this like this. I'm going to extend it to here, and then I'm going to extend it to here, and I'm just going to keep doing that all the way along, so we have a nice, neat, equidistant set of vertices for our hot dog to deform around. Then I'm going to select all, and I'm going to merge by distance, and then just make sure that has actually taken. I'm going to move this around, and you see, yeah. Okay, so we now have our hot dog, and it is split into equal parts, and the equal part is what's important, because we want a nice even distribution as it's deforming. So let's go back to object mode, and let's add some armature. Okay, and we're going to go in here into the armature object data and viewport display and in front, so we can actually see it. Now, if we move this down here and then I always get those mixed up. Rotate it so that it's sitting exactly that way. And then we're going to go into edit mode, and we're just going to do the same thing we did before. I'm going to extend, and I'm going to keep extending this so every bone is the same length all the way down. And again, it's so that we get that nice, neat equal deformation when we're deforming this hot dog. Okay, and just keep going, making sure these line up the edges in the grid, and there we have our skeleton. Let me just double check on X and Y, it's all lined up neatly. Yes, it is. Okay, so we're going to go Object, now we're going to get that, and then we get that, and Control P to parent it with automatic weights, and that should be our fully rigged hot dog. So let me just go into pose mode, take one of these, rotate it, and there we go. Yep, our hot dog is deforming. So we have our hot dog. We want to export our hot dog as FBX. Now, the transform here, so the system in Unreal is different to Blender. So we want X to be forward, and we want Z to be up. And we also want to scale this. Now, I always forget what the proper scale to use is from Unreal to Blender or vice versa. But for this, I'm just going to put in 0.1 here because that works for what we're doing. Other than that, everything else should be at default. It should be okay. We're going to export FBX. And then it's time to go into Unreal. So from Unreal, I'm going to launch 5.6. And from here, I'm going to make sure I'm clicking on Games, and I'm going to just start a blank project. Now, you might want to start with another template. It's up to you, depends on what you want to do. And I'm going to call this hot dog tutorial. Okay, once this is open, I am going to go File, New Level, and Basic, because it's just easier than using the open world template for anything. All we need to do to bring our hot dog in is Control and Space to open our content drawer. I'm going to make a folder, just good habits. I'm going to call it hot dog. Okay, and then so we're going to go to where we exported our hot dog, and we're going to drag our hot dog in here. And it's going to come up with this big import window. Now, there's a lot of stuff you can do in here, but generally speaking, if you've done your export correctly, hopefully it does everything automatically and will be fine. Try not to use your offset, rotation, all this kind of stuff. Try and get your export settings from whatever you're exporting from correct, and then you don't need to use this. If you're using this, normally means you kind of bodge something and you're taking a shortcut to try and fix it. Same with force meshes type. If we just click import, we should get a skeletal mesh, a physics asset, and a skeleton. If you see a static mesh at this point, it means you've not bound your skeleton to the mesh properly. Other than that, it should be okay. And then what happens is we drop our skeletal mesh in here. And I'm going to hit simulate whenever we're testing stuff, because if I hit play, it's going to try and create a character and a camera and everything. We don't need that. Simulate, and nothing is going to happen. Now, I could fix that by going in here and going to simulate physics. But for the purposes of this tutorial at least, we always want this hot dog to simulate physics throughout the hot dog. Okay? So we want the default behavior to be simulating physics. Everything to do with the physics behavior is held here in the physics asset, which is generated from the skeleton. So if we go in here, and I'm just going to dock this window here quickly. So you'll see here we have all the bones from the skeleton, and for each bone it's generated a volume, so a physics volume that defines how it's going to behave. And between each volume it's generated a constraint based on how the bones were put together. The first thing we're going to do is we are going to change physics type. So it says here kinematic. So default, it just follows its leader. So whatever its owner does, it will do that. Kinematic means that it is going to be physically animated. So the motion is going to be defined somehow by the game engine. And simulated means it's going to simulate physics. So we want all of ours to simulate physics. If we save, and now we go back, and now we simulate, and we have this object. Now, it's definitely not looking like a hot dog. Just to kind of accentuate what it's doing, I'm going to put a cube underneath it. Let's simulate now. Yeah, so it's simulating physics. It's not right by any stretch of the imagination, but it is simulating physics. Okay, so just to kind of highlight how that works, what we just did, if I were to take, let's take one of these bones, let's say the root bone of this whole thing, and I was to change that back to kinematic, and then I was to go here and simulate. So it's waiting for that one bone to be given information as to how it's going to move, but it's moving the rest with the simulation. And what this means is, if you imagine if you had like a character or something and you want them to have, say, a tail that is driven by physics, but you want the rest of them to be animated, or you've got, you know, like medals on a character's shoulder that you want to flap or something, you can just give those medals a bone. You can put bones in the tail, and then you can set those bones to be simulated while the rest are kinematic. But for now, let's put that one back to simulated, so they're all simulated. And let's figure out why it's not quite working. So, first things first, these are kind of weird. So Unreal has used capsules. Again, it's the curse of Unreal, and you know, it likes to default to everything is probably a character unless I'm told otherwise. So let's select all the bones in the view here. So they're all blue, all selected. So we go down here to the tools, and we've got regenerate bodies. You've got all sorts of options here about orientation to bones, skipping small bones. So if you are making, say, a character, you don't want every bone in their finger to have its own physics object. What we really want is we want to change this to spheres. Okay. That's a little bit more like it. Now, we can't see our constraints up here. We can actually turn on show constraints, but I find that gets a bit busy. If you go down here, thankfully we want all of our constraints to work the same way. So if you select all your bones, you'll see the graph here shows you where all the constraints are, and then you can just select all the constraints like that. Now, constraints have two sets of motions. They have linear motion and they have angular motion. So they can slide forward, back, left, right, up and down, or they can swing, rotate, however you want to put it. Now, in order to fully understand what is happening here, you can see that the linear limits are already locked. Let's lock the angular limits, and you'll see the stuff disappearing from here as we do. And go back, and then let's simulate, and you'll see it's a lot stiffer. It's still got a degree of bendiness, a degree of floppiness to it, because of the way these limits work and the fact that these are spheres. If we were to change this to boxes, let's reselect all of our things here and then regenerate bodies, and then go back here and simulate. You can see the way it bends slightly differently. It bends a lot, it's a lot more angular because it's using these boxes, whereas when we have spheres, the fun thing about spheres is that they kind of roll over each other. So anytime you're looking for something that's kind of fluid, it looks kind of flowing, you want to use spheres for things. So it's not looking bad. So like you could get here and you could kind of go, you know, well, we want a hot dog, we've got a hot dog. Okay, cool. But that's not how this works. That's not how design works, not how good design works. It's not about just finding the first thing that works. It's about finding the thing that is right for this project and for what we want to do. So we have to understand the nuances. We have to understand how everything works. We have to dig in and look at what all of our options are. So we're not going to stop here because it looks kind of like a hot dog. We're going to dig in and we're going to try out all the options available and find out exactly the kind of hot dog that we want. So let's go back in here and let's see what's happening under the hood. So it's all really about these physics constraints. Make sure all of our constraints are selected. And we said before that we have this linear motion and we have angular motion. Now, do we want linear motion in our hot dog? I don't think we really do, but let's try this out anyway. So if we put these all to free, you'll see these arrows appear showing that it can move freely left and right, it can move freely up and down. But if you pay attention, hold on, let's like lock this one so you can see them separately. It's not quite right. Okay, so Z is up and down, which is fine, but the Y is pointing in the wrong way. Okay, because X should really be forward and Y should be up and down. And you can tell this because the same way you get a preview for this, you also get a preview for angular motion. And if I click twist, it's defining twisting the hot dog like this. Okay, and twisting the hot dog should be, should be around this way. So our constraints are oriented the wrong way. If we want twist to face the other way, now normally under other conditions, physics constraints have their own location and rotation. So you have to think about where they're going to be hinging from and what direction things are going to hinge in. When they're in the physics asset, they don't have their own location and rotation. They're relative to both things that they're constraining, which is a little bit complicated to try and calculate and type in. So thankfully we have this preview window here. So just make sure when you're editing the location or rotation of these, you edit them in the window here, and you see that way it edits everything here. So that is twist going in the right direction. I'm also going to move them because I want this to kind of act like a chain of spheres rather than spheres that are joints. So I'm going to place them all so they're in between the things that they're constraining. Now let's lock our twist again. So do we want linear motion in our hot dog? Probably not, but let's learn about this anyway. So let's try, what happens if we put Y, which is going sideways, which is what we want. Let's try free movement on Y. And we really don't want that. So that's able to move as much as it wants on the Y plane. We really don't like that. What we could do is we could do a little bit of limited motion on the X plane. So if we put limited and then type the limit in here, and if I type something like 50, you can see these bars here for how far it's going to move. And you can see they're actually the bars are overlapping with each other here. So if I do this, yeah, it's folding back in on itself. It's kind of horrible. Set it to something a little more reasonable. Let's say 15. You can kind of see it poking out the edge here. And let's test it. So do this, and we now have this sort of slinky dog. It's not great, but let's see what we can play with here. So there's a few ways we could get this to unfold. Let's start by looking at the advanced options for the limit. So currently it is set to a hard constraint, which basically means that it cannot go past the limits that it is set. And then there's this value called restitution. This controls the amount of bounce that something has. So we could say put it to 1, and then every time it gets to the limit, it's going to bounce back, or it's going to try and bounce back. And so that's, you can see it kind of bouncing a little bit more there, but it's still not exactly what we want. Okay, so the other thing we could do is we can make this a soft constraint, which means it can actually move beyond the limits. And then it uses the stiffness, which constrains the forces that are being applied as it gets to the limit, and the damping, which constrains the velocity. We'll put something really high on the stiffness. Oop. And let's go damping about 5. And what we get now is more like a springy kind of hot dog. Now what I'm going to do is I'm going to drop that limit down to something like 5, so it's really not going to overlap with the other objects. And now we've got, yeah, you see it's got this kind of springiness to it. because it's getting to the edge and it's kind of like stiffening. If I boost this a little bit, and then if I boost the damping up, you'll see it stops springing faster. So a really high stiffness and a low damping gets us a really springy hot dog. Probably springier than we really want it to be. So there's other things that we could look at here. So you have your breakable limit, so you can create constraints that will actually fracture once they pass the threshold. And you have plasticity, which is about resetting the like resting size under certain conditions. So it's a bit complicated. We're not really going to look at those today. So what I'm going to do now is I'm going to put it back to a hard constraint, and I'm going to leave it set to just 5. So you can see how that behaves with a hard constraint 5. And it still remains kind of short. So we're going to look at a different way to drive the length back out again. So underneath the limits, we have motors. And in each case, what this does is it continually applies force to try and get to a position target and a position velocity. So we're working on X here. If I set this to 0 and I give this a really high strength, I go back here and simulate, it's pushing, constantly pushing to stay at the length it wants to be. And you can alter that strength, get different levels of push to it. That's not quite enough to make an impact. Yeah, so the motor is making a difference to it. And then the velocity target, most of the time you use a velocity target to drive to 0, but you can use it to add sort of spin or motion to things. Let's add it to like that just now. It's not going to make a huge amount of difference with the current values. Personally, I don't really want too springy a dog, so I'm going to set, but I'm going to keep the limit there. I'm just going to put it to 1 with a 50 drive, so it's got a little bit of squeeze, it's got a little bit of bounce to it, but not too much. Okay, but you know, it depends on the kind of game you're making. If you're making a really silly game, you probably want a lot more motion in that sense. That's our linear limits out of the way. Let's look at our angular limits. And if I put these to limited, you can see as I was doing that, you see we get this kind of cone shape here. If I put twist on free, it's the easiest way to look at it to understand what's going on with this visual. So your swing is producing a cone in 45 degrees on X and 45 degrees on Y, and twist is currently set to free so they can cycle like that. We want to lock our twist. Okay, so they can't spin. And then we've got our 45 degrees here that they can bend to. And this is what makes it look all kind of snaky like that. The thing to think about here is that these will compound over time. So when you have a chain of bones and a chain of constraints, the constraints compound, and each one bends more than the other in that sense. So we want these to be really, really low. And then again, we've got angular motors. Now, this thing here, slurp. So I'm not going to get into this because I'm not a great mathematician, but there is a thing called gimbal lock, where when you're like combining rotators, you can end up with a problem where they get kind of like locked on one axis. Calculating everything through a spherical lerp called slurp is one way to deal with that, which is great, but it does require that you have access to all 3 axes, which we don't have because we've locked off our twist. So we can't use slurp, we have to go to twist and swing and calculate them all separately, accepting that we could end up with a gimbal lock issue. and we are working across swing 1 and swing 2, but we want them to drive to 0. Let's just try 50 default, and it's not too bad. Let's just, for the sake of trying it, we're gonna whack this up even higher, and it should try and straighten itself out a bit more. And again, we've got options of soft constraint, hard constraint, restitution. By default, these are soft constraints right now. So again, I could be playing with the stiffness. Okay, it's actually quite nice. And the damping. But yeah, that's actually pretty good. I'm not sure about the spring. I think for me, the spring is a little bit much. I would maybe remove it completely, but it would depend on what I was doing. And so, yeah, that's basically everything that you need to know about physics constraints. And from this point on, it would just be tweaking values, turning things up and down, trying soft constraints, hard constraints, trying different drive options, and trying to figure out what it is that will give us the hot dog we want for our project. So today we looked at the physics constraint in the context of the physics asset. Now, the physics constraint in Unreal Engine can actually also exist as a component. It can exist as an actor. It's a really versatile tool. They all work pretty much the same way. So as well as using it to make parts of your skeletal mesh wobble around, you can just like attach static meshes to each other, and you can do all kinds of things like making reactive rope bridges, which use hinges and lateral motion. The trick to all of this is to be able to think in abstract, because this rope bridge, the key to it, it's not actually bound by the tips of the handrests as you might think. What it is each of those sections is hinged in the middle with a little bit of lateral motion and a little bit of angular motion. It's not perfect, as you can see. It's kind of wobbling even at rest, which is some stuff that needs fixed. But there's all kinds of stuff that you can do with these. The key thing to keep in mind is don't accept your first iteration of things. Don't just assume because it looks right that you have got it right. Dig in, explore the options, and make the most, and make the things that you want to make. Make things that are right for your project. Okay, that's great. I can't wait to see what you guys do with this.